Good morning, everybody. It is September 15th. All right, 9:15. I'm so tired of this. Miss you guys. So anyway, let's talk today about parabolas. Okay, we've already talked about it being in vertex form. So today specifically, we want to talk about it when it's in standard form. Okay, so today's objective is graphing parabolas in standard form. Okay, go ahead and write that down. Now, while you're writing that down, if you took a look at your journal, okay, now I'm just going to look at it briefly. You guys can look at it with me. We briefly look at the journal. And I'm going to go to page 51. And on my fourth period Zoom, we're going to go over this. But the standard form is in this form, ax squared plus bx plus c, where a, b, and c are just numbers, right? Just regular old numbers. We're going to talk about this special formula, negative b over 2a, and that helps us find the vertex, okay? It's also what we call the axis of symmetry because it goes right through the parabola, okay? Same thing, negative b over 2a. That's our big formula. It's not a very tough formula, remember. So if we're going to use standard form, this is standard form, okay? And if we want to find the vertex, we're going to use this little formula, okay? There's one other thing we want to look at today, and that is if by chance we want it in what we call intercept form, like it crosses here, that's an intercept, and it crosses here, that's an intercept, then you can set up the formula as an intercept. It's still going to be an x squared equation, okay? So let's go ahead and talk about this specifically, okay? All right. Oh, one more thing, minimum, maximum. Obviously, if this value is positive, it's going to be a smiley face, makes that a minimum. If this value is negative, it's going to be a frowny face, makes that a maximum, right? Increasing, decreasing means it's going downhill, then uphill. It's coming uphill, then downhill. Okay, we're going to talk about that in our lesson. So first of all, number one, let's go back and review what we've talked about. If it's in vertex form, it's nice because the vertex is in the formula. The vertex is just this number, opposite. Remember, always, always, always the opposite of that number. Go ahead and, so if it's on the inside, hopefully you guys are getting the idea that it's the opposite. Okay, and today I can explain that better why it's the opposite, okay? And then K, all right? So that's my vertex. My line of symmetry has to go through the vertex, so it's an equation. Line of symmetry is an equation. X equals h, all right? The y-intercept, to find the y-intercept is to let x equal 0. And to find the y-intercept is let, or excuse me, the x-intercept is let y equal 0, okay? So let's do example 1. Graph. So first of all, what I'm going to do is go straight for the vertex. Now the vertex is at positive 2. Positive 2 is the opposite, negative 4. Okay, I know that. So if I go to my graph and I graph 2, negative 4, my vertex is there. There's my vertex. Now I know that at the vertex, the parabola is symmetrical. So I graph in what I call the line of symmetry. And that's an invisible line. This is an invisible line which goes right through the middle of the vertex. Well, the line has an equation. So the line of symmetry is just simply, on this one, is simply going to be x equals 2. All right? Now, I also know that this is a positive 1 right here. I don't need it, it's an invisible one, but I know that this is going to be then what I call a smiley face, which makes my vertex a minimum. Minimum. There we go. Can't spell, can I? So, the vertex. Now, what about the y-intercept? Well, one way to get the y-intercept, let's see what it says. The y-intercept is to let x equal 0. All right, so let's do a little work over here. Find our y-intercept, and that's to let x equal 0. All right, so f of x and y are the same thing. So fx and y are the same thing. I can just write as y equals. So I'm going to go y equals parentheses. So it says let x equal 0. Put 0 right here. 0 minus 2 squared minus 4. Okay, let me do a little bit of math. That's pretty easy. I'll have y equals a negative 2 squared minus 4. 0 minus 2. Negative 2 times negative 2 is positive 4, so I get y equals a 4 minus 4. So I get y equals 0. Alright, so then what I know is I have a y-intercept at 0, 0. So my y-intercept is at the point 0, 0. So let me graph that. Put that point down, 0, 0 is right there. There's my y-intercept, okay? It's also an x-intercept, isn't it? But let's figure out how to find the x-intercept. So it says, well actually in this case I can just fold it over, can't I? Because it is symmetrical, so I can put the other one here, and here's my other x-intercept. Let's just do it the easy way. And then I know my parabola is going to look like this. Okay, what do we need? Okay, I needed the y-intercept. I found out the y-intercept, which is right here across the y-axis. The y-intercept is at 0, 0. I did the x-intercept. So actually two of them. X-intercept, because that's my x-axis, intercepts the x-axis in two spots. One is at 0, 0, and the other is at 4, 0. There we go. Now increasing, decreasing. Well, it's going up. It's going up over here, this direction. Going up, up, up. So it goes, it's increasing from x is greater than 0. When, I'm wrong, x is greater than 2. I hate when I make mistakes. From 2, when x is 2 or greater, when x is 2 or greater, the graph is going up. It's decreasing, it's going down, 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 back here. So it's decreasing back here when x is less than 2. Right here at the vertex, it's neither increasing or decreasing. It's just right stopped. Okay? All right, let me turn the page. So that's basically in standard form. Okay, I'm sorry, vertex form. Vertex form. Okay. Now let's look at standard form. Okay. So standard form is different. Standard form, someone multiplied the whole thing out and put it in that form right there. Okay. X squared plus bx plus c. Okay. So for example, this is in standard form. A would be 1, whatever number is in front of x squared is a, so in this case a is 1. B is 2, whatever is in front of the x variable, and then c is the constant, the number all by itself. C is negative 8. Alright, now if we want to find the vertex, we're going to use this cool formula. Okay, don't forget this formula right here. So the line of symmetry goes through the vertex. So our line of symmetry is this negative b over 2a. So it's x equals, so the line of symmetry is this little equation, x equals negative b over 2a. Will always get us to the middle of the parabola. It really does. So negative b, that's at 2 is b, so we have a negative 2. Negative 2 over 2, because 2 is in the formula. 2 is in the formula times a, and a is 1. Okay, so if we simplify this, we get negative 2 over 2, or x equals negative 1. So that's my line of symmetry. What does that mean? Well, slide up my graph. Not my graph way down here. Probably should have done this all differently, but that's okay. At x equals negative 1, we have the invisible line, which goes through the middle of our parabola. Now, I don't know what our parabola looks like yet, but I do know it looks, there is the middle of it. That's my line of symmetry. X equals negative 1. Okay? Now, let's figure out what the vertex is. So the vertex lies on the line of symmetry. So I know that the vertex has got to be on this line. So the x value, so my vertex, my x value is negative 1 something. Well, that makes sense. Think about it, okay? So the vertex is on this line, negative 1 is there. It's got to be somewhere on this line. So the x value is negative 1. So I'm just going to plug this in. So let's plug in x equals negative 1, and we'll find the y. To find the y value. So what am I saying? Well, I'm saying let's take negative 1. Let's take negative 1 and plug it in. So I'm going to plug it into my original equation, 4x. Alright, so I'm going to go y equals 1 times the negative 1 squared, because I'm plugging in a negative 1 for x, plus 2 times negative 1 minus 8. Okay? I'm just going to simplify that. I know negative 1 squared, negative 1 to a positive 1, so I'm going to have y equals a positive 1 minus 2 minus 8, which is a negative 9. Okay, that's the corresponding y value to my vertex. Okay, awesome. So let's graph that. So let's find my vertexes at negative 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. I know my y-intercept already. Okay, sorry, let me put it back up there. There's my vertex. I know my y-intercept because my y-intercept is to let x equal 0. So my y-intercept is to let x equal 0. So here's my equation. Okay, slide it up so you can see it. So my y-intercept, I'll let my x equal 0. Solve y equals, plug in 0. 0 squared plus 2 times 0 minus 8. Well, that's just negative 8, right? That's just negative 8, which on my graph is right there. Right there. Now it has a, if you flip it over, because it's symmetrical, you got that one there, okay? Now, finally for the x-intercepts. Okay, now I'm running a little out of room, but I'll slide it down for the x-intercepts, okay? So for the x-intercepts, it's going to take a little work. I'll put that up here, okay? Last year we learned about factoring. We did. Don't say you didn't learn anything about factoring. We learned about factoring last year, okay? So if we set y equals 0, we'll go 0 equals, okay, 0 equals x squared plus 2x minus 8. Let's see if you remember how to factor. Factor. We know x and x. What times what makes negative 8? Probably a positive 4 and a negative 2, because they will multiply to make negative 8, but they'll also add up to positive 2. We did this last year. So therefore, we have an x-intercept at x equals negative 4. Remember the mini equations? And x equals positive 2. So if you set these equal to 0 and solve, set this equal to 0 and solve, you know, you get negative 4 and 2. All right, so let's go ahead. Those are my x-intercepts. Negative 4, 0, and 2, 0. Okay, those are my x-intercepts. I'm going to circle those. And finally, I can put that down here on my graph. And I'm going to go to 1, 2, and negative 1, negative 2, negative 3, negative 4. And sure enough, they're equally spaced between the line of symmetry. And there is my parabola. Okay. If you have Desmos, Desmos can help you on this quite a bit. Okay. That's the math piece of it. Okay. All right. So you have an assignment. It's going to be out of your journal. You're going to need to look at page 53. And we're going to do 1 through 5. I need you to put all of it. Graph it, show increasing, decreasing, line of symmetry, graph it, minimum, graph it, and then number 6 will be the extra. Okay, that's all I have for today.